Okay, so glomerular filtration rate. So it's a rate, right? So that means that it measures how much filtrate is actually formed per minute. And I just want you to get a feeling for this, because the glomerular filtration rate for a male, they actually filter 125 milliliters per minute. So that results in 180 liters a day. Okay, now females, because we're smaller, 105 milliliters per minute, or 150 liters per day. Okay, so I want you to get the idea that the kidneys, even though they're really small, okay, they have like 21% of the blood flow of the body is going to the kidneys. Okay, so they're filtering a ton of blood. This is a lot of filtrate. Do we pee that much a day? No. Okay, normally we urinate 1 to 2 liters per day. So basically what has to happen is this 180 liters, 178 of it has to be reabsorbed. Okay, so we do not pee this much out. That would be bad, right? You wouldn't get anything done. So 99% of the filtrate is reabsorbed, and only 1 to 2 liters is actually excreted as urine. So that's why we have all those tubes. Okay, now, abnormalities. So what would happen if the glomerular filtrate rate went up? Okay, so if the glomerular filtrate rate went up, the urine output would go up. Eventually, you could become dehydrated, or you could lose some ions. You'd be losing too much. You wouldn't be reabsorbing what you needed to reabsorb. Okay, now if the glomerular filtration rate is too low, okay, so say you're dehydrated, or you have really, really low blood pressure for some reason, okay, the wastes could get picked back up. Okay, and then if you're picking back up these nitrogen wastes, that leads to azotemia, and that makes you sick. Okay, now we're going to have 3 ways that we can control glomerular filtration rate. Okay, so there's autoregulation, okay, there's sympathetic control, and then there's hormonal. So we have renin and angiotensin, our best friends. Okay, so renal autoregulation, what happens is it's pretty cool. It's just kind of like it's a reflex. It happens really fast. So the juxtaglomerular apparatus, so we went over the anatomy of that before. So what happens is if the blood pressure gets too high, okay, it will constrict, okay, the afferent arterial. Okay, so it'll get smaller. The efferent arterial will get bigger. Okay, and that'll stabilize the flow. Okay, so less blood will get in. Okay, now if the blood pressure goes down, will dilate the afferent arterial to get more blood in, and will constrict the efferent so less is exiting, and that's going to maintain the blood pressure. Okay, now our kidneys are really, really good at maintaining glomerular filtration if the systolic blood pressure is between 80 and 180 millimeters of mercury. Okay, so 80 to 180 on top. Okay, it can maintain it. So if your blood pressure is really, really extreme, okay, so if it's down around 40, or it's up above 200, okay, it can't keep the pressure going into here constant. So normally it's about 60, right? So the blood pressure going in is about 60. If it gets out of this range, we cannot auto-regulate the blood flow. So your urine output is going to suffer, and then the toxins will suffer. Okay, so here's another picture of this from the book. So here's, if the systemic blood pressure goes down, okay, we're going to increase or dilate the afferent, and it's going to allow more blood to go in here. So that's going to keep the blood pressure high. Okay, now normal, here we go, where everything is fine. Okay, but then if it goes up too high, we're going to constrict to try to slow the amount of blood that can get in here down so that we don't blow out that filtration membrane. Now this chart is supposed to show you that range. So remember I said 80 to 100, we're okay. Okay, so 80 to 100, we're all right. We can maintain the pressure. We can keep making urine. Okay, if the blood pressure is below 80, we'll stop making urine. Okay, and if it's too high, we'll make urine, and it may be that some of the glomerulus, the filtration membrane, actually gets damaged, so we end up with blood, we end up with protein and things like that in the urine. So that's just two images of the same thing. Okay, now there's two methods that are going to regulate this. So one is a myogenic mechanism. So if the blood pressure goes up, okay, that stretches the afferent arteriole. The afferent arteriole, the smooth muscle, actually constricts. Okay, and that's going to restore our glomerular filtration rate. So it's myogenic, meaning it's based on the muscle, the smooth muscle that's in there. Another way that we regulate it is called tubuloglomerular feedback, which I think is actually pretty cool. So what happens, and I know I have a picture, the macula densa cells. Okay, so here's your glomerulus. Yep, isn't that beautiful? Okay, so here's your afferent arteriole. Here's your efferent. Okay, here's the glomerular capsule. Okay, here's the PCT. Okay, that's the loop. Okay, and there's the DCT. Now, if you remember, the DCT in the real world is actually like really close to here. Okay, so the DCT, that tube is right in there. Okay, so the DCT kind of works as quality control, and it's going to monitor the concentration of the urine. Okay, so it monitors the tubular fluid, and I know I have this on the next slide. Okay, and then it's going to send signals to the afferent arteriole telling it whether it needs to constrict or dilate. So, well, here's negative feedback control. So it's all based on negative feedback, right? So if the GFR is too high, the flow is going to be too fast. Okay, so the concentration, and it's actually looking at salts, the concentration of salt is going to be too low. Okay, and the macula densa cells, which are in the DCT, they detect that. Okay, they're going to send the message to the afferent arteriole. Okay, so don't worry about that. To afferent arteriole, and the afferent arteriole will constrict, okay, and slow this down. So it's just negative feedback. Okay, now, I know I wrote it down about quality control and the JGA. It must be on the next slide. It's in here, so we'll talk about it. There's more information on it. Okay, now, if you're exercising or circulatory shock, okay, we don't want a whole bunch of blood. Like, we don't want you to make more urine if you are in your fight or flight, and if you're in sympathetic. We don't want more urine. We want the blood supply to go to the skeletal muscle. Okay, so strenuous exercise, circulatory shock, they're going to tell the afferent arterioles to constrict. Okay, glomerular filtration rate, urine production are going to go down. Okay, the blood's going to go to your heart. It's going to go to your brain. It's going to go to the skeletal muscles. It's going to be redirected. Okay, so norepinephrine, epinephrine will be released. Those are constrictors. Okay, so that's the reason why you don't pee. You're not making as much urine when you're scared. Although sometimes you pee, but that's more because the sphincters that are controlling the bladder relax. But in reality, you're not making as much urine. Okay, and that's the last slide.